students, in the last class we were discussing about Newton's advancing difference method of interpolation, and we have solved one problem under that method. In today's class we will solve some more problems under that method, and the problem is the table shows the expectation of life at different ages. Interpolate the expectation of life at the age 26, and they have given age in years and expectation of life in years. Age is 15, 20, 25, 30 and 35, whereas expectation of life is 30, 29, 27, 24 and 20. Now we are asked to interpolate the expectation of life for the age 26. So first of all, in the solution we are going to think that let x and y be x as age and y as expectation of life. Expectation of life. X and y be expectation age and expectation of life. That means this will be x and this will be considered as y. Now see, we are going to estimate the expectation of life when x is equal to 26. So first of all we should see whether 26 is given in this x data series. But 26 is not given. 25 is given but 26 is not given. That's why we can't interpolate under binomial expansion method. We can interpolate the value of y when x is equal to 26 under the method of Newton's advancing difference. So since we are going to write as since the value to be estimated is not one of the value of x series. So we are going to apply Newton's method. To estimate the value at x is equal to 26. We are going to estimate the expectation of life for the age 26. Since now we are going to see how many values of y is known. See, 1, 2, 3, 4, 5. 5 values are known. That's why we are going to find out the leading difference. Since there are 5 known values of y, prepare leading difference table. Leading difference table as below. Now we are going to prepare the leading difference table. So the first column is in leading difference table. First column is x. Second column is y. Next, leading differences. In that, first order, second order, third order and fourth order. Up to fourth order leading difference we are going to find out, because 5 values of y is known. That's why up to fourth order leading difference we are going to find out. First of all, we will write the values of x. X values are 15, leave one line. Next 20, 25, 30, 35. These are the values of x. Next, we are going to write the value of y. 29 minus 30, it is minus 1. This is delta 0 raised to 1. Next, y2 minus y1. 27 minus 29. It is minus 2. Delta 1 raised to 1. Next, 24 minus 27. 24 minus 27. It is minus 3. Delta 2 raised to 1. Next, 20 minus 24. 20 minus 24. Which is equals to minus 4. That is delta 3 raised to 1. Now next, second leading difference. Delta 1 raised to 1 minus delta 0 raised to 1. That is, it will be like this. Minus 2 minus minus 1. Minus 2 minus minus 1. So minus 2 minus into minus, it will be plus. Greater number sign is minus. Plus into minus, it will be minus. 2 minus 1, it will be 1. So minus 1. Delta 0 raised to 2. Next, minus 3 minus minus 2. Minus 3 minus into minus, it is plus 2. Minus greater number sign is minus. Plus into minus, we are going to minus it. 3 minus 2, it will be 1. So minus 1, delta 1 raised to 2. Next, minus 3 minus 4 minus minus 3. Minus 4 minus minus 3. Minus 4 minus into minus, it will be plus 3. Minus 1. Again it will be minus 1, delta 2 raised to 2. Next, we are going to find out the third leading difference. Delta 1 raised to 2 minus delta 0 raised to 2. That is minus 1 minus minus 1. Minus into minus plus, it will be. So minus 1 into plus 1, it will be 0. Delta 0 raised to 3. Next, this is also same. Minus 1 minus minus 1. Minus 1 minus into minus plus 1. So minus 1 plus 1 gets cancelled. It will be 0. Delta 1 raised to 3. Lastly, minus 0 minus 0. It is 0. Delta 0 raised to 4. So this is the leading difference table. This is the leading difference table. Now we will find out the value of x. Here the first differences in each column is called leading differences. First differences in each column. First this difference, next column first difference, third column first difference, and fourth column first difference is called as leading differences. So these values we are going to consider in the calculation of y formula. Now we will find out the value of x. You know the formula is the value of x to be interpolated minus the value of x at the origin. Value of x at the origin divided by the difference between two adjoining values of x. Two adjoining values of x. Values of x. So this is the formula to calculate x, the value of x. So let us calculate it by substituting the values in that formula. So it will be value of x to be interpolated. What is the value of x that we have to interpolate? It is 26. We are going to interpolate the value of y for x is equal to 26. That's why x is equal to value of x to be interpolated is 26 minus value of x at the origin, that is beginning value of x, it is 15, divided by the difference between two adjoining values of x. What is the difference between the adjoining values of x? It is 5. So difference is 5. 11 divided by 5 is equal to 2.2. Value of x is 2.2. Now for the formula we need x minus 1, x minus 2 and x minus 3. First of all, we will find out the value of x minus 1. I will write it here. X minus 1 is equal to x value is 2.2. 2.2 minus 1 is equal to 1.2. Next, we need the value of x minus 2 is equal to 2.2 minus 2 is equal to 0.5. y0 plus x delta 0 raised to 1 plus x into x minus 1 divided by 2 factorial delta 0 raised to 2, or else you can simply write it as 0 2 plus x into x minus 1 into x minus 2 divided by 3 factorial 0 raised to 3 plus x into x minus 1 x minus 2 into x minus 3, because 5 values are known, that's why up to here, divided by 4 factorial 0 raised to 4. So this is the formula. Now we will substitute the values in this formula. First y0 value in this table, y0 value is 30. So write it as 30 plus x value. Just now we have calculated it. X value is 2.2 into delta 0 raised to 1. What is the value of delta 0 raised to 1 in the leading difference table? It is minus 1. So 2.2 into minus 1 plus x is 2.2 into x minus 1. X minus 1 value is 1.2 divided by 2 factorial. 2 factorial is 2. 2 into 1. It means 2. 0 raised to 2. Delta 0 raised to 2 value is minus 1. So into minus 1 plus x value is 2.2 into x minus 1 is 1.2 into x minus 2. X minus 2 is 0.2. So 0.2 divided by 3 factorial. 3 factorial is 3 into 2 into 1. That is 3 2 is the 6. 0 raised to 3. That is delta 0 raised to 3 value is 0. Plus x value is 2.2 into x minus 1 is 1.2 into x minus 2 is 0.2 and x minus 3 value is minus 0.8 divided by 4 factorial. 4 into 3 into 2 into 1. 4 3s are 12, 12 2s are 24 into 0 raised to 4. Delta 0 raised to 4. The value of delta 0 raised to 4 is 0. So into 0. Now we will simplify the equation by simplifying. First it is 30, write as it is. y26 is equal to 30 plus 2.2. First we will multiply the signs. Plus into minus, it will be minus. 2.2 into 1, it is 2.2. Next plus into plus 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 into minus, it will be minus. 2.2 into 1.2 into 1 divided by 2. It is minus 1.32. It will be minus 1.32. Next, anything 2.2 into 1.2 into 0.2 into 0. That means anything multiplied by 0 will be 0. So plus 0. Here also 0 is there. So if you multiply this with 0, it will be 0. Which is equal to 30 minus 2.2 minus 1.32. Answer is 26.48. Therefore, the expectation of life at the age 26 is, we can write the conclusion as the expectation of life at the age 26. At the age 26 is 26.48. 26.48. So thus we have interpolated the expectation of life at the age 26 under Newton's advancing difference method. Now we will solve one more problem under this method where x values are slightly different from the problems which we have solved previously. earned by workers, wages earned by workers per week in a certain factory. In a certain factory. In a certain factory. Calculate the number of workers earning more than rupees 650. Earning more than rupees 650 per week. And the information given are weekly wages in rupees. Next, number of workers. Weekly wages are up to rupees 500. Next, up to rupees 600. Next, up to rupees 700. Up to rupees 800. Next, up to rupees 900 and up to rupees 1000. And the number of workers are 50, 150, 300, 500, 700 and 800. So that means here they have given the information regarding the wages earned by the workers in a factory. In a factory, workers are working and what are the wages earned by those workers are given. And we are asked to calculate the number of workers earning more than rupees 650 per week. Here the information given is wages up to rupees 500. Those employees who are earning up to rupees 500 is 50 workers. Next, 150 workers are earning the wages up to rupees 600. Next, 300 workers are earning the wages up to rupees 700. That means it includes 150 plus 50 workers. Those who are earning 500 and 600. That up to 700 means they may earn 500, they may earn 550, they may earn 600. Up to 700, there are 300 workers. Next, 500 workers are earning the wages up to rupees 800. Likewise, totally there are 800 workers in a factory who are earning up to rupees 1000. So totally there are 800 workers. And we are asked to calculate the number of workers earning the wages more than rupees 650. So first of all, we will consider, we are going to calculate the number of workers earning the wages up to rupees 650, not more than rupees 650. First of all, we are going to calculate the number of workers who are earning the wages up to rupees 650. So we are going to use the Newton's advancing difference method. So Newton's method will be applied to ascertain number of workers earning more than rupees 650 per week. Next, here we have to compute Next column is number of workers. Next it will be leading differences. In leading difference up to fifth leading difference. First order, second order, third, fourth and fifth. Up to fifth leading difference we are going to calculate. First of all, let us write the weekly wages of workers. So weekly wages, first one is up to 500. So up to 500, leave one line. Next up to 600, up to 700, up to 800, up to 900 and up to 1000. Next, number of workers earning up to 500 is 50. Next it is 150, 300, 500, 700 and 800. We will give the values as y0, y1, y2, y3, y4 and y5. Now we will find out the leading differences. y1 minus y0. 150 minus 50, it is 100. 150 minus 50, it is 100. That is delta 0 raised to 1. Next, 300 minus 150, it is 150. Delta 1 raised to 1. Next, 500 minus 300, it is 200. Delta 2 raised to 1. 700 minus 500, 200. Delta 3 raised to 1. Next, 800 minus 700, it is 100. Delta 4 raised to 1. Now, next second order leading difference will be 150 minus 100, it is 50. Delta 0 raised to 2. Next, 200 minus 150, it is again 50. Delta 1 raised to 2. 200 minus 200 is 0. Delta 2 raised to 2. 100 minus 200, it will be minus 100. Delta 3 raised to 2. Next, 50 minus 50, 0. Delta 0 raised to 3. 0 minus 50, it is minus 50. Delta 1 raised to 3. Minus 100 minus 0, it is minus 100. Delta 2 raised to 3. Next, minus 50 minus 0, it will be minus 50. Delta 0 raised to 4. Next, minus 100, so it will be like this. We are going to calculate like this. That is minus 100 minus 50. So minus 100 minus into minus plus 50. Greater number sign is minus. We are going to deduct it. 100 minus 50, it is 50. So here it will be again minus 50. Delta 1 raised to 4. Next, minus 50 minus 50. Minus 50 and you are going to deduct it from 100. So difference is 100. 650 minus 500 divided by 100. Value comes to 1.5 because 150 divided by 100 will be 150 divided by 100, so it is 1.5. So value of x is 1.5. Now we are going to find out what is the value of x minus 1, x minus 2 and x minus 3 and x minus 4 because up to fifth difference we have calculated. So up to x minus 4 we need the values. X value is 1.5 minus 1. It is equal to 0.5. Next x minus 2. X value is 1.5 minus 2. It is minus 0.5. Next x minus 3. 1.5 minus 3 is equal to minus 1.5. Next x minus 4. 1.5 minus 4 is equal to minus 2.5. So these are the values which we are going to substitute in the main formula. The formula of y is, so now we are going to write the formula of y 650. Up to 650 we are going to calculate. First we will write it as y is equal to y0 plus x delta 0 raised to 1 plus x into x minus 1 divided by 2 factorial 0 raised to 2 plus x into x minus 1 into x minus 2 divided by 3 factorial 0 raised to 3 plus x into x minus 1 into x minus 2 into x minus 3 divided by 4 factorial 0 raised to 4 plus x into x minus 1 x minus 2 into x minus 3 into x minus 4 x into x minus 1 into x minus 2 into x minus 3 into x minus 4 divided by 5 factorial up to 5 factorial because up to fifth leading difference we have calculated 0 raised to 5. So this is the formula. Now we are going to substitute the values in this formula. y0 value in the leading difference table. Value of y0 is 50. 50 plus x value just now we have calculated, it is 1.5. So 1.5 into delta 0 raised to 1, that is first differences of each column. Delta 0 raised to 1 is 100. So into 100 plus x value is 1.5 into x minus 1 value is 0.5 into divided by 2 factorial is 2, 0 raised to 2. 0 raised to 2 value in the difference table is 50. So into 50 plus x value is 1.5, x minus 1 value is 0.5 and x minus 2 value is minus 0.5. It is 0.5, here it is minus 0.5 divided by 3 factorial 0 raised to 3. Delta 0 raised to 3 value is 0. Next plus x value is 1.5 into x minus 1 is 0.5, x minus 2 is minus 0.5, x minus 3 value is minus 1.5 divided by 4 factorial 0 raised to 4. Delta 0 raised to 4 value in the leading difference table is minus 50 plus x value is 1.5, x minus 1 is 0.5, x minus 2 is minus 0.5, x minus 3 is minus 1.5 and x minus 4 is minus 2.5 divided by 5 factorial 0 raised to 5. interpolation of value of y under Newton's advancing difference method. So this is slightly different from whatever problems we have solved in the previous classes, where values of x were directly given, but here values of x are not directly given. It is given as up to rupees 650 or 500, 700 like that. That's why this is the method we are going to solve problems when such kind of question is asked. So other problems we will solve or discuss in our upcoming